The matrix M is given there, represents an enlargement first, followed by a rotation. So I'm going to show a couple of different methods of doing this. Method 1 is the slightly more longer but general way of doing it. So we have our enlargement matrix, we're doing that first, hence why it's on the right hand side. Then we have the rotation matrix, we're doing that second, hence why it's on the left hand side. Multiplying that out, I've got the cos theta times k plus minus sine theta times 0. Then we've got the cos theta times 0 plus minus sine theta times k. Then the sine theta times k plus the cos theta times 0. Then the sine theta times 0 plus the cos theta times k. So this is the combination of an enlargement followed by a rotation. And then comparing, the k cos theta would have to be equal to the minus 5 over root 2. The minus k sine theta would have to be equal to the minus 5 over root 2. So therefore those two minuses would cancel out and give me this. And I could then solve these two equations simultaneously by dividing them. So I could do the bottom divide by the top. The k's would cancel out, and this is going to allow me to work out what tan theta could be. And then I'll need to substitute back to work out k and so on. Now, that's a general way of doing this question. It's not how I would do this particular one, though, because I think there's a quicker, easier way we can do it via inspection. Because considering we've got 5, 5, 5, 5 involved in all of these, and we've got this 1 over root 2, 1 over root 2, 1 over root 2, I'm thinking just by inspection that k is probably 5, because then we will have this times this plus this times this does give this. This times this plus this times this does give this. This times this plus this times this does give this. And this times this plus this times this does give this. So therefore, just by inspection, I can say that my value of k, and therefore the scale factor of enlargement, is 5. And I can also compare and say that cos theta needs to equal minus 1 over root 2, which when I do cos inverse gives me 135. And then I'm just going to draw a quick cos graph to check the other answer. So minus 1 over root 2 is roughly here. The 135 degrees is here. So this is 135. So this is 135. So the 360 minus the 135 is 225. So these are the two angles of theta that give cos as minus 1 over root 2. I'm then going to compare with the sine thetas. The sine theta has to equal 1 over root 2. So when I do sine inverse of that, I get 45. And then again, just draw a quick sine graph to find the other value. Here's my sine graph. When does it equal positive 1 over root 2? We've got the 45 degrees there, where this is 45. So there will be another solution here, which is 45 less than 180. And 180 take away 45 is 135. So sine 135 is also equal to 1 over root 2. And now we're looking for both of those to be the same angle. So therefore I know that it's going to be a rotation by 135 degrees anti-clockwise. That's part A and B of the question done there. Part C. We are told that a point P is mapped onto a point P dash under M. So point P is mapped by the matrix M to be P dash. We're told that the coordinates of P dash are A, B. We need to work out the coordinates of point P. We need to work out what X, Y is. Well, if I multiply both sides of this matrix by the inverse matrix, then we will work out that the point xy is the inverse matrix times the point AB. To work out the inverse matrix, have a look over here. I first worked out its determinant by doing A times D minus B times C, A times D minus B times C, which gives 25 over 2 plus 25 over 2, which is 25. So the determinant of that matrix is 25. So therefore my inverse matrix, I've divided by the determinant, then I have swapped the A and the D around, which actually doesn't make any difference in this case. And then I've changed the signs on the B and the C. So this is positive, this is negative. One other thing I did before I actually substituted the inverse matrix in here is I just noticed that the 5s here will cancel with the 1 over 25. So basically I've just factorised that 5 outside. To get 5 over 25, which is the same thing as 1/5. And this is now the inverse matrix that I've used here, which when multiplied by the point AB, so I've just kept the 1/5 at the front, this times this, plus this times this, and then this times this, plus this times this, and there we go. This is my new x coordinate, and this is my new y coordinate in terms of A and B.